Electrical shock hazards can unexpectedly arise, even where established safety protocols are followed. Electrocution can occur in seemingly safe settings for several reasons. Neutral wires are typically grounded, but if the grounding is faulty or compromised, current can flow through the neutral wire and cause a shock. This can occur due to loose connections, damaged wiring, or even a temporary fault. Ballasts in fluorescent light fixtures can store residual voltage even when the fixture is turned off. If the ballast is touched while working on the fixture, this residual voltage can deliver a shock. Emergency lighting typically relies on batteries or capacitors to provide backup power. If these components are not properly isolated or if there is a wiring fault, they can store charge and cause a shock. Other factors contribute to the chance of shock. Wet clothing or sweaty skin can increase the conductivity of the body and make it more susceptible to shock. Using damaged or poorly maintained tools, cords, or fixtures can create shock hazards. When working under pressure or for extended periods, it's easy to become complacent or make mistakes that can lead to shock. To minimize the risk of shock in all electrical settings, there are precautions you can take. Firstly, always work with insulated tools and wear proper protective gear, including gloves, safety glasses, and arc-rated clothing. Secondly, inspect equipment and wiring regularly for damage or faults. Thirdly, test for voltage before working on any circuit or component. Fourthly, use ground fault circuit interrupters, known as GFCIs, and arc fault circuit breakers, called AFCs, to protect workers from electrical hazards. Finally, stay aware of the potential hazards present in every electrical environment. Seek immediate medical attention if you experience any electrical shock, no matter how minor it may seem. Remember, working with electricity always carries some risk. By understanding the potential hazards and taking appropriate precautions, you can significantly reduce the likelihood of an electrical shock incident. When a neutral wire carries current, it's usually a sign of an imbalance in the circuit. In a balanced circuit, the current flowing through the hot wire returns through the neutral wire, ideally with minimal voltage difference between the neutral and ground. However, several factors can cause the neutral wire to become energized. One common cause is an overloaded circuit. When a circuit is overloaded, the current demand exceeds the circuit's capacity, leading to voltage drops and potential current flow through the neutral wire. Another cause can be a ground fault, where a hot wire comes into contact with a grounded surface or equipment. This can create a path for current to flow through the neutral wire as it tries to return to the source. Improper wiring is another significant contributor. If the neutral and ground wires are inadvertently connected at some point in the circuit, it can create a parallel path for current to flow through the neutral wire. This is a dangerous situation that can lead to electrical shock or even fire. Damaged or corroded connections can also increase the resistance in the neutral wire, causing voltage drops and potential current flow. It's essential to regularly inspect and maintain electrical connections to ensure they are secure and free from corrosion. To prevent neutral wire shocks, ensure proper grounding throughout the electrical system. Grounding provides a lower impedance path for fault currents to flow back to the source, tripping the circuit breaker or fuse and de-energizing the circuit. Use ground fault circuit interrupters, GFCIs, in areas where there is a risk of moisture or contact with grounded surfaces. GFCIs are designed to detect even small imbalances in current flow and quickly interrupt the circuit, preventing an electrical shock. Regularly inspect electrical wiring and equipment for damage or wear. Replace any damaged or worn components immediately. Ensure that all electrical connections are tight and secure. Use appropriate tools and techniques when making electrical connections to avoid damaging the wires or terminals. Avoid overloading electrical circuits. Distribute the load evenly across multiple circuits to prevent excessive current flow. If you're unsure about the safety of an electrical circuit, consult a qualified electrician. They can perform a thorough inspection and identify any potential hazards. Ballasts used in fluorescent and high-intensity discharge HID lighting systems can pose a shock hazard even after the power is turned off. This is because ballasts contain capacitors that store electrical energy. When the power is turned off, the capacitors can retain a charge for some time, potentially delivering a shock if touched. There are several types of ballasts, each with its own characteristics and potential hazards. Magnetic ballasts, commonly found in older fluorescent fixtures, use inductors and capacitors to regulate the current flow to the lamp. Electronic ballasts, which are more energy efficient, use electronic components to control the current. Both types of ballasts can store residual voltage, but electronic ballasts typically discharge faster. The amount of residual voltage stored in a ballast depends on its design, capacitance, and the amount of time it has been energized. Some ballasts can store hundreds of volts, enough to cause a painful or even dangerous shock. To prevent ballast shock, always disconnect the power to the lighting fixture before working on it. Use a voltage tester to verify that the power is off and that there is no residual voltage present in the ballast. Wait for the ballast to discharge completely before touching it. Some ballasts have a built-in discharge resistor that helps to dissipate the stored energy. If the ballast does not have a discharge resistor, you can use a screwdriver with an insulated handle to short-circuit the capacitor terminals. Be careful not to touch any metal parts of the screwdriver or the ballast while doing this. Wear insulated gloves and safety glasses when working on ballasts. This will help to protect you from electrical shock and arc flash. Never assume that a ballast is safe to touch just because the power is off. Always test for residual voltage before proceeding. Regularly inspect ballasts for signs of damage or overheating. Replace any damaged or worn ballast immediately. Follow the manufacturer's instructions for installation and maintenance of ballasts. Emergency lighting systems are designed to provide illumination during power outages. These systems typically use batteries or capacitors to store energy and provide backup power to the lights. While emergency lighting systems are essential for safety, they can also pose a shock hazard if not properly installed and maintained. Batteries used in emergency lighting systems can store a significant amount of energy. If the batteries are damaged or improperly handled, they can release this energy in the form of an electrical shock or fire. Capacitors used in emergency lighting systems can also store charge even after the power is turned off. This residual voltage can deliver a shock if touched. Wiring faults in emergency lighting systems can create shock hazards. If the wiring is damaged or improperly connected, it can create a path for current to flow through unintended objects or surfaces. To prevent emergency lighting shock, always disconnect the power to the emergency lighting system before working on it. Use a voltage tester to verify that the power is off and that there is no residual voltage present in the system. Wear insulated gloves and safety glasses when working on emergency lighting systems. This will help to protect you from electrical shock and arc flash. Regularly inspect emergency lighting systems for signs of damage or wear. Replace any damaged or worn components immediately. Follow the manufacturer's instructions for installation and maintenance of emergency lighting systems. Ensure that emergency lighting systems are properly grounded. Grounding provides a low impedance path for fault currents to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Test emergency lighting systems regularly to ensure that they are functioning properly. This will help to identify any potential problems before they become a safety hazard. Moisture significantly increases the risk of electrical shock. Water is an excellent conductor of electricity, so when your skin is wet or damp, it reduces the body's resistance to electrical current. This means that even a small amount of voltage can cause a significant shock. Sweat, rain, and humidity all contribute to moisture on the skin. Working in damp environments, such as outdoors during rain or in areas with high humidity, increases the risk of electrical shock. Wet clothing can also conduct electricity, so it's essential to keep your clothing dry when working with electricity. To minimize the risk of shock in wet or damp conditions, take precautions. Firstly, wear rubber-soled shoes. Rubber is an insulator and will help to protect you from electrical shock. Secondly, wear rubber gloves. Rubber gloves will provide an extra layer of insulation between your hands and any electrical conductors. Thirdly, avoid touching metal objects when working with electricity. Metal is an excellent conductor of electricity, so touching a metal object while working with electricity can increase your risk of shock. Fourthly, use ground fault circuit interrupters, GFCIs. GFCIs are designed to detect even small imbalances in current flow and quickly interrupt the circuit, preventing electrical shock. Fifthly, keep your work area dry. If possible, work in a dry environment. If you must work in a wet or damp environment, take extra precautions to protect yourself from electrical shock. Damaged or poorly maintained tools, cords, and fixtures can create significant shock hazards. Insulation on electrical cords can become frayed or cracked over time, exposing the wires inside. This creates a path for current to leak out and cause a shock if touched. Tools with damaged housings can also expose internal electrical components, creating a shock hazard. Improper grounding of tools and equipment can also lead to electrical shock. If a tool is not properly grounded, a fault current can flow through the user's body, causing a shock. To prevent shock hazards from faulty equipment, inspect tools, cords, and fixtures regularly for damage or wear. Replace any damaged or worn components immediately. Ensure that all tools and equipment are properly grounded. Use ground fault circuit interrupters, GFCIs, to protect workers from electrical hazards. Follow the manufacturer's instructions for the maintenance and repair of tools and equipment. Remove any damaged or unsafe tools from service immediately. Fatigue and lack of attention can significantly increase the risk of electrical shock. When you're tired or distracted, it's easy to make mistakes that can lead to electrical contact. Working under pressure or for extended periods can lead to mental and physical fatigue. This can impair your judgment and slow your reaction time, making you more susceptible to electrical shock. Complacency can also be a factor. When you're used to working with electricity, it's easy to become complacent and overlook potential hazards. To minimize the risk of shock due to fatigue and lack of attention, get enough rest before working with electricity. Take breaks regularly to avoid fatigue. Focus on the task at hand and avoid distractions. Be aware of the potential hazards present in the electrical environment. Never rush when working with electricity. If you're feeling tired or distracted, stop working and take a break. If you are not qualified to work with electrical equipment, do not attempt it. Call a qualified electrician. Firstly, plan the job. Think about the shock risks. Secondly, look at the work area. Thirdly, use safe work practices. Fourthly, use the correct tools. Fifthly, use tested and approved tools. Sixthly, consider all overhead power lines to be energized. Seventhly, keep a safe distance from overhead power lines. Eighthly, wear the right protective equipment. Ninthly, never touch someone who is in contact with electricity. Tenthly, immediately call for medical help.